z-score. So we just looked at the normal distribution, and here we're going to look at the z-score, or the standardized score, which it can be called, and it relates to the standard deviation and the mean of a normal distribution. So we've already looked at a normal distribution, and we're going to draw up a basically the same one we had before, where we have a normal distribution with the mean, median, and mode of 50, and standard deviation again is going to be 5. So one standard deviation below is 45, one standard deviation above is 55. Now, the z-score is a way to reference these instead of saying one standard deviation below, one standard deviation above. So we call the mean, median, and mode a z-score of 0. One above has a z-score of 1. One below has a z-score of -1. So for something that's 2 standard deviations below is going to have a z-score of -2, and something that's 2 standard deviations above is going to have a z-score of just 2. So positive and negative values tell us if it's above or below the mean. Now, there's a formula to work out the z-score as well, and that formula is going to be the z-score is going to equal the score that you want to analyze minus the mean of all scores, which we give that symbol there, x with a bar over it, divided by the standard deviation. So that's the score that you want to analyze. This is the mean, and this is the standard deviation. All right. So let's have a look at an example. So let's consider doing 2 tests. One where you get 40 out of 50, and the mean of that test, so the average, was 45, and the standard deviation was 5. And another test where you received 40 out of 100, the mean was 30, and the standard deviation was also 5. Let's see if we can do a bit of a diagram to represent this. So let's draw a normal distribution for each one. Which test do you think performed better in? 40 out of 50 or 40 out of 100? So this one, the mean is 45, and in this one, the mean was actually 30. So if you got 40 out of 50 in this one, that's actually below the mean by 1 standard deviation, which means you got a z-score of -1. In this one, the mean was 30, and you got 40 with the standard deviation of 5, so 1 standard deviation above is 35, because just added the standard deviation. Add another 5 for the standard deviation, you're on 40, and you got a z-score of 2. So because this z-score is higher than this z-score, you could actually argue that you perform better with the 40 out of 100 than the 40 out of 50. You can even use the formula to find those z-scores. You don't have to do that diagram every time. So let's just see how we can do that. So we know the z-score equals score minus the mean over the standard deviation. So we got our score, we got 40 minus the mean, which was 45, divided by the standard deviation, which is 5. And that gives us 40 minus 45 is -5 over 5, and that's -1, which is the z-score that we got by drawing the diagram. You can do the same thing for the other one, where the z-score is going to be the score we got, which is 40, minus the mean, which is 30, divided by the standard deviation, which is 5. 40 minus 30 is 10, 10 divided by 5 is 2, and we get the same z-score that we got with the diagram. Now, in the second case where we got 40 out of 100, so we'll just write those values again. We got 40 out of 100 with a mean of 30. The mean was 30, and the standard deviation was 5. Now, if 40 students did the test, so 40 students sat the test, how many scored? So how many scored between 20 and 35? So for this, it is actually helpful to draw a diagram. So we'll draw a normal distribution. We'll put the mean in. The mean was 30. And we're after scores between 20 and 35. So to do that, we're going to have to go 2 standard deviations below. So 25 and 20, and 1 standard deviation above, which we're going to get 35. Now, we're going to have to use our percentage knowledge to get this out. We know when you're in between a z-score of -1 and 1, we know that's 68% of all scores. And between a z-score of -2 and 2, that's 95% of all scores. So if we do 95 minus 68, that's going to give us 27%. And that's the leftover parts out here, the 27. That's from there to there. And if we divide that by 2, it's going to tell us what each one of those things is worth. And we're going to get 13.5%. So this little bit here is 13.5%, and this little bit all the way to 40 is another 13.5%. So now we can work out the percentage of students who got between 20 and 35. So between 20 and 35 is from here to here. So we can just add the 68% with one of the 13.5s. So we're going to go 68 plus 13.5, and that's going to give us 81.5%. And if 40 students sat the exam, we can now just find 81.5% of 40. So we can do 81.5 on 100 times 40. That's going to give us 32.6, but we can't have 0.6 of a student, so we can round it up to 33 students got in between 20 and 35 for that exam.